Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called It is Chaos, or Is It? By 72K Chun Shuai. I think that's how you pronounce it. Here are the rules. We have chaos construction rules where we need to divide the grid into regions of orthogonally connected cells. And we need to place the digits 1 through 6 once each in every row, column, and region. What is an orthogonally connected region? It's a region where you can go from any cell in that region to any other cell in the region just by going through edges, all while staying within the region. So this is an example of an orthogonally connected region. To get from this cell to this cell, you can just go through all of these edges and stay within the region from getting from here to here. What is not an orthogonally connected region is something like this, because these two cells, even though they can get to each other by just going through edges while staying within the region, they can't get to the other cells in their region by doing so. They would have to either go through a corner or go through an edge while exiting the region, which is not allowed. So that is how orthogonally connected regions work. We have circles in the cell, in the grid, where a digit in a circle indicates exactly how many circles contain that digit. So, for example, if we had a 2 here, that would mean there are 2 2s in these circles. Additionally, it indicates how many of the up to 9 cells in its 3 by 3 neighborhood, including itself, belong to the same region as the circle. So, for example, if this were 2 and this were 2, that means only exactly 2 of that cell in the 3 by 3 box surrounding itself, centered on the circle, are in the same region as the circle. So you could have 2 going that way, you could have 2 going this way, we don't know. But you would have exactly 2 of the up to 3 by 3 area that's centered on the circle, which would be in the same region. And that's how circles work. For squares, we have a digit in a square indicates how many of the up to 8 neighboring cells, excluding itself, are in a different region from the square, and not all possible squares are given. So for a digit in a square, it indicates how many of the 8 neighbors are in a different region, from the square. So if this were, say, 5, that means 5 of the cells surrounding the square would be in different regions. And finally, we have numbered rooms, where clues outside the grid indicate the digit which has to be placed in the nth cell in the corresponding direction, where n is the digit placed in the first cell in that direction. So, for example, if this were, say, a 2, or actually, let's make it a 3. If this were, say, a 3, that would mean 4 has to be placed in the third cell in the corresponding direction, because the clue is the 4 outside of the grid. The 3 is equal to the n, so that means it's the nth cell, because it's the first cell in that direction. And that's saying that 4 has to be placed in the third cell, so 4 would have to be there. Furthermore, the first n cells must all be in the same region. And the n plus 1th cell, if it exists, must be in a different region. So if this were, say, 3, that would mean that these 3 cells would have to be in the same region. And this cell, the nth plus 1 cell, which is the 4th cell, must be in a different region. So we would know that this is a different region here. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so the digits in circles. So, okay, for a numbered room clue. So we are guaranteed if the numbered rooms clue is not a 1, the first digit can never be 1, right? Because if you have a 1 there, it's saying that that digit has to be in the first position, which would already be occupied by the 1. So obviously, if it's not a 1 as the number rooms clue, you are never going to have a 1 as the first digit in that row or column. So these digits must be greater than 1. And in addition, since they are part of the same region, the first n digits are part of the same region, these have to be the same region, these have to be the same region. Since these are all the same region, this must be part of that region. So we'll mark it as orange. And one of them has to extend further. We don't know which, though. It cannot be 3 and 4 here. So one of these has to be 2. Because if we tried to have 3 and 4 here for the length of that, well, obviously this can't be 4. So another thing about number rooms clue is the digit in the number rooms clue cannot be the first digit either. So if we tried to have a 4 here, that would say that the 4 has to be in the fourth slot. But obviously we have a 4 in the first slot, which makes that not possible. So that's why this can never be 4 here. So these 4 are in the same region, guaranteed. So that means this must be, the 4 has to be in the second or third slot. It cannot be the fifth spot because that would be too many digits in the same region. And for this could be 2 through 4 here. So this is 2, 3, 4 here for the end. This is 2 or 3 here, which means, and 4 cannot be here because they are in the same region. So this is a 2, 3 pair here. So that means one of these is 4 or 5. We're not sure which. And the other one has to be in the position here. So we guaranteed a 5 here. We're guaranteed a 4 here. Same with these numbered rooms clue, right? So these have to be in the same region because this can never have a 1 in it. This can never have a 1 in it. So these have to be the same region. These have to be the same region. So they're all in one region. This again is still 2 or 3. This has to be red. We can't get to 5. We can't get to 4 because 4 is guaranteed to be one of these 2 digits here. So 4 has to be one of these 2. And then 6. So if we try to have this be 4, this can't be 4. If we try to have 5 here, that's too many cells in the region. So this also has to be 2 or 3. And then we have a 6 is one of these 2 cells. Okay. For this cell, if it's part of this region here, so say this was 3, and that forced this to be 6. That means 6 of these cells, neighboring cells, would have to be not in the same region. So it would have to be all of these 6, which is possible, actually. This is up to 4 here, because there can only be 4 cells that are part of its same region here. So this has to be 1 or 4. It cannot be 1, because if this were 1, the problem is it has to orthogonally connect to the rest of its region, and you're necessarily having to be one of these is part of its region. So this can't be 1, which means this is 4. So all the circles are 4. Since this is 4, this must be part of the region here, right? So this must be 3 cells showing that that's the region. So then this is 2 here, which makes that a 6. So this is not a 6 here. This is 4. It's part of the red region. And we know this is a boundary here and this is a boundary here. Because as part of the numbered rooms clue, the nth plus 1 cell must be a different region. Okay. This cell already has 3 cells that are not part of its region. So it has to be at least 3. So this is 3, 4, or 5 here. Cannot be 4 because of 4 in the row. And the reason why we knew all these were 4 was because the circles indicate exactly how many circles contain the digit. Well, we have 4 circles and there's a 4 here, so that means there must be 4 fours in circles, which means these are all 4. Okay. 4 has to be one of these 2 digits here, remaining in column 2. This is 1 or 5 here for the red region. This has up to 5 cells that are not part of its region. So 1, 2, and 5 is here. This could be up to 6, but it doesn't have 4 available. So 1, 2, 3, 5, 6. So all 4 of these cells are part of its region, so that's green. All 4 of these cells are part of its region, so that's blue. This only has 4 cells that are part of its region. Obviously, none of these can be 1. Or actually, no, they could be 1. Never mind. If this is part of the green region, we already have 2 that are not part of its... Sorry, if this is a green region, you could only have 1 more here in this neighborhood to be part of its region. So it would have to be 2 at least here, which are not part of the region. If we try to have... Okay, so this can't be 2 greens here. This can't be green, can't be red. Because if we try to have 2 greens here, these 2 cells have to be part of a region, but they can't be part of green because green is full. And red already has 5 cells, so that can't be both red. So this cell would not have a region if that's the case. So this can't be green, it can't be red. So we're going to make this one pink because it can't be green, it can't be red. So it's a different region than all of these. This already has 3 cells in it that in the neighborhood, which are not part of its region. Otherwise, it could be all pink here, if that's the case. So this could be green, cannot be red. We could have green, pink, or yellow here. If it's green, this is guaranteed to be 2, at least. It would have to be 2, because we have green as part of its region here, and this could be the most that you could have here in the 3x3 box surrounding this square. This has to be 1 or 6 because it can't. 5 is one of these 2 cells and 4 is one of these 2 cells. So if this is green, this is 2. If it's yellow, it can never be 5 here, right? Yeah, if 5 of its neighbors are in a different region, it doesn't have a region, essentially. So this is 1 or 2. If it's green, obviously it has 2. If it's pink, it has at least 2. So this is always going to be 2 then. So this is 2, no matter what, which means this cannot be 2. Of these neighbors, you can only have 5 of them be in the same region. So we're guaranteed at least 3 cells here, which are not in the same region. This can't be a yellow because that would force this to have 3 cells in the surrounding the square, which would not be part of its region. So this has to be green or blue. Sorry, green or pink. If this is green, then this could be red here. So either this is green and that's green, or this is pink. This can't be 4 because of 4 in the region, which means this has to be a 4 here, which means this cannot be green. So if we try to have that as green, the problem is it would have multiple cells. Oh, I guess it could go this way. So you could go green. So now if this is green, it has to go green, green here. If this is pink, this would be pink here. So this can never be red, which means this is green or pink there. This is pink, definitely, because we have to have a 4. That eliminates 4 from being here, so this must be 4 here. And this must say, from the number of room clues, that must be 2, this must be 3, which makes that 5. So then that's boundary there, that's boundary there. This is orange. So both of these are pink. One of these is red. We don't know which. This 4 has to be part of yellow because we have already... Every other region has a 4. 2s. 2s are here, here, here. Where's a 2 in row 2? It has to be here. That means the remaining digits in row 2 are 1 and 6. The remaining digit in the green has to be, cannot be 2 here. So it would be 3 or 5 here. 6 eliminates 6 here. So this is 1, which makes that 6. Remaining digits in column 1 are 1 and 5. This pink, obviously, if all of these are pink, this would be 5. Sorry, this would be 3. Otherwise, to have 5 in the same region, it can't be just these 4 and then these digits. So I think these are guaranteed to be pink no matter what. So these are pink no matter what. This is definitely a boundary. Can this be green? The answer is maybe. Yeah. Well, okay, if this is green and green, that would force this to be pink there. But then this couldn't be green, and therefore these would all be pink here, which is 7 pinks, which is not allowed. So this can never be green, which means this has to be orange. Since that's orange, this is done as a boundary. This has to be 1 or 6, which eliminates 1 and 6 in the rest of the row, so this is 3 or 5. This is a different region. Can never have 6 because we only have, these 3 are not part of the same region. So this is a 3-5, 3-5 pair in the pink region, which means this can't be 3 or 5, it can't be 2 or 4, this is 1 or 6 then. We have blue here. Red cannot go this way, so red has to go this way. Right, because this couldn't be red going up here once and then green going here, because that would be too many cells that were not part of its region, right? That would be 6 cells that are not part of its region. That's the reason why we know this has to be pink. So then red is done that way. This is either blue or yellow. We're not sure which. This is obviously either pink or green. We don't know which. So then this is a boundary here. Blue can only go up to these amounts. Cannot go here. Because it would then block these cells from having a region. So blue could go to any of these. Yellow could obviously be any of these. 6 eliminates 6 here, so that's 1 and 6. Can this ever be pink? And the answer to that is no, because these 4 cells are already not part of its region, so it must have 5 cells in the surrounding neighborhood. So this has to be 5. So this is 5, that's 3, this is 5, which means this is not part of its neighborhood, so this is not pink, it's green, which makes that not pink, it's green. That leaves these as not green, it's pink. So that's done as a region. This has only 4 cells that are part of its region. Huh. 5 eliminates 5 here, so that's 3. This can't be 5, it's 1, which makes that 6. 1 eliminates 1 here, so it's 5 and 1. That leaves this as 3. Remaining digits in row 5 are 1, 2, and 5. This can't be 1 or 5 because of 1 or 5 in the column, so this is 2. This is 1, 5 as a pair. We have 2, 6 remaining in... No, 2, 5 remaining in row 4. And this can't be 2 because of 2 in the column, so this is 5, which makes that 2. 5 eliminates 5 here, so it's 1 and 5. This cannot be blue, because if that were blue, that it would not... You would have a duplicate in the region. So this is 4 cells surrounding this circle, which are part of its region. Therefore, this cannot be, which makes that blue, which means this can't be, so that's blue. So these cannot be blue, and this is basically just a normal 3x3 Sudoku, with that being 1, this being 6, and that being 3. Okay. Huh. Interesting. I've never actually done a chaos construction where the actual construction yielded a normal Sudoku division, but here we are. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I guess that's why it's called It Is Chaos, or Is It? And I guess I'll see you next time on Frank Puzzles. Take care.